Let's continue with derivative of a product. Product means multiplication. So here we have a function y equal to uv. So you can see that here we have a function times with another function. So say that y is in terms of x. Therefore, u and v here should also be in terms of x. So we'll get ux times vx. So all the functions should be in terms of the same unknown, which is x in this case. Instead of writing it like this, you can just call yx as y, ux as u, and vx as v. So that's why we have y equal to uv. So let's differentiate y equal to uv. Differentiate y, you'll get dy over dx. Now, what if you differentiate uv? You'll get vu prime plus uv prime. So this is the formula of product rule for differentiation. So whenever you need to differentiate a function and then you can see that it has a product, you need to apply this formula. So let's look at this example 6a. As you can see, we have a product here. This function times with this function. So both of them is in terms of x. So let's call the first function as u and the second function as v. So write down both functions. Now, differentiate each function. Differentiate u, you'll get u prime. Differentiate 2x cubed will give you 6x squared. Differentiate minus x will give you minus 1. Now let's differentiate v equal to 11 minus 7x squared. Differentiate v, you'll get v prime. Differentiate 11 will give you 0. Differentiate negative 7x squared will give you negative 14x. So that's your u prime, v, and v prime. So let's differentiate this equation. Differentiate fx will give you f prime x. On the right hand side here, we have the product uv. So if you differentiate uv, this means that you need to use product rule. And the formula of product rule is vu prime plus uv prime. So let's substitute everything here into the formula on the right hand side. First, we have v, which is 11 minus 7x squared. Next is u prime, which is 6x squared minus 1. Next, we have u, which is 2x cubed minus x. And the last one is v prime, which is minus 14x. So simplify everything here. So by simplifying, negative 42x to the power of 4 minus 28x to the power of 4 is negative 70x to the power of 4. 66x squared plus 7x squared plus 14x squared is 87x squared. And the last one is minus 11. And that is the final answer of this question. There's actually another method of finding f prime x for this fx. Since fx is 2x cubed minus x times 11 minus 7x squared, instead of using product rule, you can try and expand fx first. And now we can differentiate fx to find f prime x. And hence you can see that f prime x that we got here is the same as f prime x that we got using method 1. So for this kind of question, since fx is something to the power of 1 times something to the power of 1, you can use two methods. The first method is product rule, and the second method is to expand fx first before you differentiate. So the second method is only applicable when you have fx equal to something to the power of 1 times something to the power of 1. But what if you have y equal to 2x squared minus 1 squared times x plus 1? How do we find dy dx for this function? If you try and apply the second method to find dy dx, this will be harder for you to find dy dx since you need to expand y first before you differentiate to find dy dx. So for this question, it is much easier for you to use product rule.